What's up guys, this is Ronnie. Welcome back to our channel Total Technology. So finally we are here. So as per our earlier discussions, so I already told you that from mid of February or first week of March we are going to start our machine learning series. So this is the prerequisite of those machine learning series which we already discussed. So we are going to talk about Numpy first, then pandas, then matplotlib, and parallelly we'll be going to run our linear algebra on all the mathematical topics which are essential for machine learning and data science. And after that probably it will take 2 or 3 months time, and probably in the end of May or June we are going to start our actual classes on machine learning. But it will be very slow and we will be going to we'll be going to do deep dive of every session, every topics, and there will be lots of tutorial, lots of hands-on, and probably you guys can also interact with me via some sort of question, doubt, or you can send me direct email, because I know this is going to be very challenging for most of the students. Those are not familiar with any mathematical topics earlier, but they are very much interested to learn data science and machine learning. For them actually we designed this course, so it will be kind of fully covered with all the prerequisite, all the mathematical topics required, and also we are going to deal with not only theoretical parts but again also with the coding part as well. So everything will be there, but before I'm driving towards the course, I just want to set some motivation, guys. Whatever we are teaching on daily basis, we need to follow us, we need to do some sort of practice, and you need to do proper like hands-on as well, or else it will not going to help you, because as I told you, this is heavily on the mathematics and as well as coding part. So if you are coming from non-CS or non-computer science background, but again you are having strong intuition or strong inspiration towards data science, or you are having some sort of aspirations to become a future data scientist and all, then definitely you need to do proper practice, or else it will be it will not be going to help you. Our videos, or watching our videos, is not going to help you. So again, there will be total 3 tutorials will be running parallelly. One will be like Numpy, and after that we'll start the pandas, and after that we'll be going to start the matplotlib. So this is from the foundational point of view for machine learning and data science, because Numpy, pandas, and matplotlibs are building blocks of machine learning. And apart from that, we definitely need to know linear algebra, calculus, statistics, probability, and other topics as well from the mathematical point of view. So everything will be there. So it will be going to be hardcore technical as well as like analytical like tutorial. So not only programming, not only technical, you need to think analytically, you need to you apply your logical sense as well. So then only you will become a proper machine learning engineer or data scientist in the future. So enough of talking, guys. So in this tutorial we're going to talk about Numpy. So most of you already heard about Numpy, but probably already worked with Numpy, but I'm just going to start with the very basics of Numpy, so it will be easier for all of you to understand the core concept behind Numpy, why we use Numpy, and why it is so much important or so much popular in the data science for a data scientist, and for a data scientist job, or those are working on a data scientist, they probably use Numpy millions of time on their daily to daily life. Okay, so this is actually introduction tutorial, and we'll be going to talk about what is Numpy and why should we use Numpy and why this is so popular. Okay, so let's move on to the next slide. So what is Numpy? So Numpy is the fundamental package for scientific computing in Python. Again, it's a Python library. Obviously it's a Python library, but it's written in C. It's provide multi-dimensional array object, various derived objects such as mask array, matrices, and an assortment of routines, first operations on arrays, including mathematical logical steps. So I'm not going to go through the slide, because anyways I'll be going to upload this slide as a separate tutorial reference. You guys can go through it, but I took this reference from the Numpy official website. You guys can go through, just search in Google Numpy documentation, Numpy official, you will get everything there. So I'm just going to give you the meat part of the library. So Numpy is a multi-dimensional array object. Like, it provides a library, it's a Python library which supports multi-dimensional array objects. So those are already familiar with Python, they know using Python array you cannot create multi-dimensional array. It is more or less similar to the list, but in array you can have homogeneous object, in list you can have heterogeneous object. Means in array, Python array, you can have only single type of element, and list you can have multiple, but in numpy array you can have also homogeneous element, because if you're storing integer, all elements should be integer. If you're storing some sort of character string, it will be character or string. And again, it's written in C, that is why it is very fast. But again, this is very high level statement. If you should use numpy, because this is very fast. But again, we are going to experience this in the next slide, why this is very fast. Okay, but before that, how to install numpy? This is very simple. Pip install numpy, you will get your numpy install. But if you want to learn more about the installation or other process, you can just visit this website. Okay, so next slide, why should we use numpy? So here comes our coding part. I'll explain this thing with code. So basic building block or basic concept behind using of numpy is that everyone, I think all of you, probably 90% know, we should use numpy as a data scientist, because we are going to deal with the huge amount of data, so it will be faster. We know this thing, but why this is fast? Why this is faster than usual Python array? So we'll experience that. Our library, which is numpy, and we can use some alias. So this is kind of universally acceptable coding standard. Like whenever you see this line, or if you're not following this line, it means you are not doing something correctly. You have to do it. Like there is nothing wrong if you are not importing this as np, or you can use anything as, but np is kind of a standard, so which is followed by mostly in the Python community, and also as well in the data scientist and all the machine learning enthusiasts. Okay, so first thing, we import our library. Then let's say we'll define one declare one numpy array object. So for that we need to use np.array. Okay, so here I'll use 10,000 objects, so we can like just blindly follow my this tutorial for the timing. Just an arrangements, it is going to create like 10,000 object, and the all starting with 0, and there will be one like kind of gap. So I'll explain you. Like if you think, so see, it is 0 1 2 and up to 9,999. This is the meaning of this function, which is followed which is provided by numpy. And we'll now define on we'll declare one normal list. So it is going to be list, and we'll do the same thing, range, and inside that we'll write 10,000. Okay, so same thing. Okay, so what we'll do, we'll now sum up this one and this one. Okay, and we'll try to calculate the time. So calculating the time, it is not going that we are going to use some sort of stopwatch, rather we'll be using sum b. Okay, let's see the timing now. So how long it will take to sum up all the elements using this sum method. Okay, so this is taking 72.6 microsecond. Okay, like this, and after that we'll use this one on top of this. So now we'll use is this time it, and we'll use np. We're using numpy sum on numpy data structure, because this is a different data structure and this is also a different data structure. This is numpy array, this is normal Python list. Okay, so let's see the timing now, but the objects are same. Okay, so we'll see some like what do you say, some deviation on the times. Okay, so see, it is taking only 30 like microsecond, and it is like 72 microsecond, almost 5 times higher. Almost not almost 5, exactly 6 times, almost 6 times higher. So if you increase the 0, let's increase the 0. Okay, and let's run this thing again. Okay, let's run this thing again. Now it is like 100,000, here also 100,000. So see, it is 787 microsecond, and for this thing, see now what is going to return. See, still it is within 100, within 70, so almost 10 times. So now we are only talking about 100,000 record, but at the real time or the real life scenarios, we are going to deal with like millions of record. So that times this like microsecond will become like minutes, and here it will be always like some second. So 10 times means huge, if you are getting my point. Like we are only dealing with 100,000 records, so that is why it is now just coming with like microsecond. But the basic difference is that it is so basic like fundamental fundamental observation is that whatever time is taken by Python array using Python summation method is higher, 10 times higher than numpy, like which is actually been taken by numpy data structure using numpy summation method. So this is the main fundamental point. So now you understand why we are talking about numpy is fast. So this is the reason, and I have explained you everything from coding point of view. So what I'll do, I'll just upload the whole thing as a separate Jupyter notebook. So let me delete some part. Okay, like this. So what I'll do, I'll upload this notebook as a separate separate code file into my GitHub repository. Don't worry about that, you guys will get the code as well. But try to understand that when we use numpy data structure, it took only 70 microsecond, and here it takes 787 microsecond, so almost 10 times difference. And so numpy data structure is always faster than normal Python data structure. So now you understand my point. So now I'll explain you like why this is fast. So what I'll do, before doing that, we need to write everything here, so it will be easier for all of you to understand. Okay, so remove. Okay, so what I'm doing, I'm just updating the slide so it will be easier to understand. Okay, and after that we'll write this code. Okay, this, and you need to run this thing from Jupyter notebook, or else it will not work, because this will not going to work in your IDE. Only in Jupyter notebook it will work. So why should we use numpy? The reason is numpy data structure is always faster than Python data structure. So we are talking about list and array. Okay, and also in Python data structure array, you cannot like define or declare multi-dimensional array. But now I am going to discuss a bit about why numpy is fast. So let me remove this part. Okay, why numpy is fast. So there is no coding, but you need to understand. This is completely intuitive, so rather I'll explain you. Okay, so I need to draw something. Okay, so let me take a pencil here. So suppose this is normal Python list. So you have like this, and here some address, like this is one address, this is one address, this is one address, this is one address, and this is one address. And every address is pointing to the elements like 1, 2, 3. Like for example, you have x, here you also some value, some value. And in the memory, in the Python list, actually in the adjacent location, all the location of those values has been saved as a pointer. And pointer means here it is having some location x, and actual memory block in the x location, the value 1 will be stored. Okay, and like this, if the second element is 2 and here the address is y, so in the yth location in the memory, the 2 value will be stored. So now I suppose just imagine you want to sum up all these elements, so you need to run the loops. Definitely you need to run loops. Now every time for getting one element, you need to first come here to get the address, and then you need to look up to get the actual element value. So for every element, there there is actually two operations simultaneously. One, getting the address value of the location and fetching the exact value from that location. So every time for single element fetching or single like element searching or summation, you need to do back and forth 2 times for the lookup. So for all the elements it is going to be increased, like kind of a overhead. So that is why it is taking much time. But in case of numpy array, so it is kind of dense array in the memory and where the actual value has been stored. Okay, so you don't need to do any kind of address lookup or anything back and forth, nothing like that. Whenever you require, you just go to that place and you will immediately get access to the element. So there is nothing called pointer or nothing called address lookup or data fetching up or something similar to this what is happening in Python. So that is why whenever you are doing to do some sort of summation or whatever operation with the object within the numpy array, or you want to do something with element wise operation, you need to just go to that point and you need to find the element, and that's it, it's direct. And so that is why the numpy version of the array is much more faster than the Python version of the array and list. So this is a fundamental difference. So guys, I know I'm not very good at drawing, but I'm just explaining you the things. Like in Python, in the memory address, when you are talking about list, it is actually going to hold this thing in the stack as a form of adjacent address. So now I'm going to some technical details. So stack means stack is actually holding the address of your actual element. So when you are going to get the element, you need to first go to the stack, get the address of the location, and then you need to look up and you need to find the object from here. Again, you suppose you need third element, so you go here in this location, you get that address is z, and again you need to go here, find the z location, and you need to get the element value 3. So for getting 2 elements, you need to do 4 operation. First you need to come here to get the address value, and from again you need to come here to get the value from that address, actual value of the address. But again for the second element, you need to come here to get the address. Okay, you need to go to the address z, and again you need to come here to get the value, actual value for this position from z location in the memory 3. So for single element fetching, you need to do you need to run 2 times kind of lookup. One is first address lookup, and after that from the address you need to look up the actual value retrieved. Okay, so that is why Python version of array and list is much more slower than the numpy version of the array or numpy data structure. So that is the basic things. Like in numpy, everything is direct, there is no lookup, no memory address related pointer. But just remember this thing, for Python there is a pointer is like pointing towards the actual element. In numpy there is no pointer, it's a dense array and every elements are stored in the exact position. And in Python, your memory location of those elements actually been stored in the array. So whenever you are going to retrieve that value, you need to go to that location, you need to get the value, and then you can like do some operations. So that is why it is very slow when you are going to deal with larger values like millions, trillions of data. Because when you are talking about data science, our objective is to build like data pipeline, and after that do some sort of operation. Don't think about that we are going to do some sort of operation in CSV. Yes, CSV is good when you are playing or running something for your own benefit, but don't think about that. In the enterprise level, you will get data in the form of CSV. There could be multiple channel, multiple pipeline, there millions, trillions of data will be coming in unstructured format. Then you need to structure those data using some big data techniques, that's different. And after that you will get semi-structured or structured data, and on top of that you need to apply your algorithms. So algorithm means machine learning algorithm or data science algorithm, but it is actually built upon this numpy, matplotlib and pandas feature. Okay, so until and unless you are not solid on numpy, pandas, matplotlib and mathematical foundation of machine learning, then you will not be able to develop or like describe your model or to get the effective results. So try to understand this thing. So, and I hope I am clear that you guys understood that in Python the array and list are kind of memory address lookup, not direct. but in NumPy it is direct lookup. So that is why Python versions are much more slower than the NumPy version. So I hope it is clear now. So I'm not going to upload this slide, guys. It doesn't look good. So probably I can change this thing with some sort of diagram, then it will be easier for all of you to understand. But for the time being, just remember this thing, and also I'll be going to upload the code as well. So this is first tutorial on the introduction side. Actually I forgot to remove the name. Actually still it is Rust. So in the morning I uploaded one tutorial on Rust, so don't worry about that. I'll change the headline, but here it is same. So this is introduction of the NumPy. So from next year or the next tutorial onwards, we'll be going to talk about some other important like aspects of NumPy. So that's it, guys. Hope you guys will enjoy this series, cause most of you are already start sending me email kind of a reminder. I know I kind of delayed to upload this series, but don't worry, guys. From now onwards it will be kind of continuous, this machine learning series. So that's it, guys. We'll see you in the next tutorial very soon. Till then, take care, goodbye, and hope to have a good time with I hope you all have a good time with our new series. So that's it. Once again, have a nice day, take care, and keep watching us, keep following us, keep supporting us. That's it.